Okay, it is
Okay.
recording from now.
Yeah, I see. Thank you, Dolores. Okay. Hello, everyone. Thanks for coming here. As you see in the slide, this is a training event promoted by CyclOps, the CyclOps project, and it is about the so-called impact chains, which are, as you can read, a conceptual modeling approach for climate risk assessment. So, yeah, first of all, as you see, I'm talking also on behalf of my colleague Silvia Cocuccioni, which also provided much of the content of this event. So thanks. And but as you will see, also this is the like a line of research of a whole group. So it's not just about me on these two people, as you will see.
De qué tipo de estación?
Krisa, sorry, I think you. Okay, thank you. So first of all, some fancy slides about the place I work, which is Eurac Research here in Bolzano, Italy, South Tyrol. This is a private center founded in Bolzano in 1992, and it has a lot of different institutes promoting health and clean energy, even efficient political systems. And you see, this is a photo of Bolzano. You have a lot of vineyards. And so we try to cope with global issues, but also very often apply to the regional scale of South Tyrol. A bit of numbers. So this is quite an international center. Most people come from Italy, but also you have representation from all over the world. And this is the list. You see, it's a long list of institutes and centers which compose Eurac Research, and we are this one underlined, the Center for Climate Change and Transformation, which I will talk also a bit more in detail now, quickly. So what do we do here at the Center for Climate Change and Transformation is basically monitoring and modeling climate change and its impacts and risk in the Alps, but also not in the Alps. Of course, we are very focused on the Alps and in mountainous areas. So here we are on the map, you see. And so usually what we do is we have, thanks also with the collaboration of other institutes like above all the Institute for Earth Observation, we have all these geospatial data sets like climate and weather and all these maps, which then we try to translate into, so we try to study all the processes on Earth, all the spheres. So you have also very importantly the cryosphere in our area, so glaciers and all about snow, which is getting less and less, of course, and but also hydrosphere, biospheres, natural hazards like you see here, landslides or rock falls. So we try to translate. Either somebody should be muted. Thanks. And so yeah, we also try to translate the images basically from satellites or climate models and try to translate them into knowledge about the Earth processes and risks. So and when you try to translate these data into this more elaborate concept of risk, that's where all the conceptual modeling leaks in. You see here, these are actually impact chains, as you will learn. And finally, the actual final goal of our center is to also then, as a final output or outcome of all these analysis, to provide recommendations for climate adaptations and for a more optimized or better risk governance. That's the in a nutshell. Yeah, you have also, okay, of course, transversally data management, but in a nutshell, that's a bit of the story about Eurac Research and the Center for Climate Change. There's some photos, and this is the group I was talking about before. So I'm not just talking on behalf of Silvia, but also all this group. We are basically all joining forces to achieve the goals. And yeah, I'm sorry for bragging. We're very proud. Also, our head of the institute, Mark Sebish, was at the last IPCC scoping meeting in Kuala Lumpur. You can see him there. And yeah, that's about the workplace. Now a bit also about the project, which is promoting this event. So CyclOps, which it's kind of joining the words of data life cycle and data ops. So it's an operationally oriented project, which, okay, yeah, now some number first. You see, this is, okay, it's pluri-international, many companies from Spain, Italy, and Greece, also some friends in Germany and other countries. It's a big project, and it will last until end of next year. And this is a bit the concept. You see here on the lower part, you have so the use cases, which at Eurac Research we, among with other partners, are implementing one of these. And on the other hand, you have this European data spaces concept you might know about. And then through the CyclOps platform, you see that it's intermediating between the use case, the end user application, and the data spaces. So try to implement the use case through, you see, many components also. Of course, try to, through AI and natural language processing, make an easy interaction with the end users, which are usually non-technicians. And yeah, that's a bit very, very shortly what the project is about. And you see here, it has appeared the impact chains that's where it's located in all this project. Okay, the outline for today, it's this, about us. Okay, about us, I've said it already. And so we'll go through, first of all, the concept of climate risks. I guess that probably none of you are very fond of them. So we will go through all the important information to be prepared to at least know about the impact chains, which are really not complex stuff. So it's going to be easy for you. And we'll also try, it's a training event, we'll try to do a bit of hands-on, let's say. So we will try to build an impact chain so you get a feeling of what it means to build one, because it's a simple tool in a way, because it has to be used by non-technicians, but the complexities of things to be modeled can be very harsh. And finally, just an outlook on the ongoing and future developments at Eurac Research. Okay, let's start with the climate risk concept. So the first is the definition of risk. Okay, now we will see a lot of words and definitions. I do just keep them for reference. The probably most important idea you see on the right here in the sketch, that you see risk. You might have seen this. It's a PCC diagram, and tells you very graphically that how risk is defined, which is a combination of three components. On the top, you have the hazards, the climate hazards. Think about, storms or landslides. And then you have exposure, which is like the elements which are exposed to risk, like can be the population, very basically. And then you also have the vulnerability component. So how the exposure, how much the exposure is exposed to risk is modulated by the vulnerability component. So you have here the IPCC definition, which says that risk is the potential for adverse consequences. Then you have the United Nations also definition, which is the potential loss, which is determined probabilistically as a function of hazard exposure and vulnerability. And then you also have an ISO definition, which is, again, you see the potential, and it talks about likelihood. So you see the risk is it's all about the how likely, what is the probability of certain impacts to happen. Okay. Then, so we have defined climate risk. And so what is usually the workflow for it's called the climate risk assessment. It's a CRA. So you see, this is usually what is done for a proper climate risk assessment. You have, okay, on top you have all the data, of course, and information, and then you have all these sequential steps. First and above all is usually the scoping. So you have to define what you want to analyze, which is the temporal and spatial domain which you want to focus on, the sectors of society you want to calculate the risk on. So this is very important, because otherwise, if you just try to model the whole universe, you usually end up with nothing. So it's a very important first step. And then you see you have the identification. So you have to give names, actually real exact name to the actual risk you want to calculate. And then you go forward with analysis and evaluation, and this might be, and then also towards adaptation. So the idea after you evaluate the risks, so how to cope with this risk, so how to adapt, for example, what can we tell the society and risk stakeholders, what can we recommend to adapt to what is coming. And usually also you see there is the purple, the monitoring and evaluation. So usually all this risk assessment you can do on a specific area. You also usually do it periodically after some years to keep a monitoring and how things evolve in time. So that's also usually what happens. And you see, usually the output is a climate report. So you have this document which you then give to stakeholders, decision makers who might need this report. So you gather all this information into a document. Okay, so some more acronyms. I'm sorry for that, but I think they are also important to know. So you might have heard of DRR, so disaster risk reduction, which is very much related to disaster risk management. Is really closely intertwined. So yeah, I mean, it's usually about the policies and the measures that can be employed to anticipate future disasters, and yeah, the management is how to manage the reduction. So it's really close concepts. And then you have also another one, which is this comprehensive risk management, CRM, which is a way to mean that disaster risk and assessment, climate risk assessment should be done in a holistic approach. So not really focusing just on, I don't know, the actual hazard you want to calculate the risk about. So this must be really systemic or holistic view on the whole actors that play. Indeed, oftentimes what happens is that disaster risk assessment focuses only on single hazards or on direct sectoral impacts, and have a static view of the risk, and do not consider indeed the even sometimes rapid changes in the drivers of risk. So that's usually the non-comprehensive risk assessment. And yeah, so but actually in reality, the reality is very much more complex. You have multiple kinds of hazard which can happen also together at the same time. You have cascading, so you see you have all these types of different hazards that can occur at the same time. You talk about compounding of events, one after the other in a cause-effect relationship. So you have a cascading of events, and you have also other types of relations. So just to underline that usually it's usually interconnected, and that's when you talk about multi-hazards. And then there is the multi-risk also, because also with just one single hazard, you can impact on more than one sectors or regions. So there are yes, different areas of sectors, or can spread across. You have cascading impacts as well, you see. So this is what usually, so when you take into account all of these aspects, then you usually talk about this comprehensive risk assessment. Some more acronym. I'm sorry, I'm almost done. But this is also another very important one, is CCA, so climate change adaptation. So all these disaster risk reduction existed also before climate change and climate warning was raising. And so this is a new concept, which is, we will see a bit slightly different. And you see through now, thanks to the Climate Adapt project, we are also defining guidelines on how to do proper climate change adaptation. You see, you have several steps, and usually in step 2 and 3, which is like assessing the climate change risks and identifying as well the adaptation options. This is where also the impact chains can be usually employed. Yeah, so this is also just put here a list of what are this is not a static definition, it's just the result of an effort in trying to understand how can risk assessment be done in a comprehensive, holistic way. So these are like the 10 commandments. So I'll just put them here and we can go through them quickly. So you see the first is to put the human and ecological systems at the center of the whole analysis. Of course, accounting for climate change, and recognize that the nature of risk is complex and systemic. It cannot be simplified. So also you have to apply an inclusive risk governance and multidisciplinary approaches. Use the concept of risk tolerance, and then try to go as much as you can with nature-based solutions to adapt. Integrates, as we saw before, different sectors and levels, so in a multi-way, and strengthen communication, information, and knowledge, and finally use iterative and flexible processes. So these are many principles, but so just to give you an idea of what we're talking about. You might have heard of climate change mitigation. This is sometimes they get overlapped together. There is, you see in the graphics, some overlap in them, but they are very different, separate concepts. So you see, mitigation is all about decarbonizing, actually. So, and it's more of a global, let's say, towards global thinking. So you have to reduce CO2 or equivalent emissions, and this is what mitigation is about. Whereas in climate change adaptation, which is what we saw before, it's very much more focused on the regional or anyway local application. So how in Bolzano, how in South Tyrol are we going to adapt to all the changes due to climate? And yeah, I wanted to go also quickly through. Yeah, it's important to see the differences because you've seen many concepts. You've heard about many concepts. Now you might have been a bit busy, but it's important to underline the differences. So, for example, what is the difference between climate change adaptation and disaster risk reduction? You see, usually disaster risk reductions focuses on, which existed way before climate change and all this. So usually, disaster risk reduction focuses usually on all hazards, not just the natural one, but also human-made. And the time horizon, so the time scope is usually more on the short term, like preparedness and response to actual disasters, whereas climate change adaptation has a more long-term view on how to even transform society for the future. The approach for disaster risk reduction is to reduce the existing risks usually, or future upcoming ones, whereas CCA is focused on how to cope with the changes in the conditions due to climate change. And even at the policy level, the disaster risk reduction usually refers to the Sendai framework for disaster risk reduction, whereas IPCC is the reference for climate change adaptation. Okay, so the first section is done. Now we can, I think, of course, you can, sorry, I forgot to mention, you can interrupt me, or if you have already some doubts or questions regarding these first concepts, please just pick up. Otherwise, after this introduction, we can now talk about the impact chains. So remember climate risk? I hope it was a few minutes ago. So it's this again, as you see in the graphics. So just to summarize, it's the composition, the union, let's say, of these three components: the hazards, the exposure, so like the exposed elements, like buildings, population, and the vulnerability of them. So yeah, you have hazard which cause a cascading of a chain of potential impacts, and the impacts usually affect these exposure. You see, for example, ecosystem and people livelihoods. So this is the exposure on the left, and you have on the right, you have the vulnerabilities, which modulate how the impacts impact the exposed elements. And so from all of this, you try to define, get a definition of risk. So impact chains, you see very briefly, it's a conceptual model that is used to better understand, systemize, and prioritize the different factors that drive risk. So you see, we have seen this diagram just before, and then so the idea is that the impact chain tries to translate this into an actual diagram of typed boxes and typed relationships. So let's go also into the details of the single elements of risk. So we get also a feeling of the variety that lies within modeling risk assessment. So regarding the hazards, you see you have a wide range of different types of hazard, from heat related, precipitation related, wind, snow, etc. And usually you have two big categories of hazard. You have the rapid or even extreme events, like can be storms or heat waves. And then you have more slow onset, they are called processes and trends, which also represent and can be modeled as hazard, like the increasing temperatures due to climate change. This is a more detailed view of all the types of hazard. I will not go through all of them, just to give you an idea of the universe behind this concept. And you see you have compounding events, events which change magnitude, duration, or frequency, and are modeled differently. Many different hazard types. Then you have the exposure. So again, exposure is defined as who or what is exposed to the risk or to the hazards. So you know, most prominently you have us, the population. So very important, but also the building and the ecosystems, etc. Yeah. Okay, these are a lot of text. We don't have to, but I think the concept is clear. And then lastly, the third one is the vulnerability. So usually, as you see, also you can see in the figure. So vulnerability defines, like modulates how impact the adverse conditions due to hazards can impact on the population. So of course, elderly people are more vulnerable than non-elderly. So this is, if you have this information, it's a very valuable also to really map in a more coherent way risk in the region. So you see, it's the propensity, predisposition to be adversely affected. And you see from these diagrams, this is also a very complex concept. These are a possible categorization of vulnerability. You have different dimensions: the economic, physical, environmental, etc. And you see you have, vulnerable groups. You see you can have, for example, how many refugees are present in the population. There's a very vulnerable section of population. What is the food conditions? And then you have a lot of socioeconomic indices around, and also at the level, not just the population, but the institutional level, you have the scoping capacity. measures. So how is your the place you live able to cope with disaster? So this is another level which measures the vulnerability of the area of interest. Finally, this is the another, we saw the three concepts which compose risk, but then you also have these other actors which play, for example, the underlying risk drivers. So you see here in the picture, these are kind of more, you see, you have also the arrow above. So you have the current state, but going through the potential future, that's where these underlying risk drivers come into play. So they are more slow processes which might have to be taken into account in the assessment. Okay, that's about the concepts of impact change. Just to have a look at, just to see in the phase one, this is, I put an example. Okay, this is a toy example. You see, this is very simple, but as I told you, this is a diagram of elements, of typed elements. You see, you have like yeah, the yellow and green. So these are different types of elements in the model, and in also you have different types of the relations. Now it's not clear, it's not visible from the picture, but all the arrows are also typed. So you have different kinds of relations. And finally, there is also this, you see, wetland restoration, reforestation, all these boxes which are kind of snapped above the diagram are for example, adaptation options. So, okay, we model the situation of risk here. What do we recommend? This is a slightly more realistic example. You see, so the modeling can grow quite complex. You remember what in the principles, you have to recognize the complexity. But this, yeah, impact change can grow also much bigger than this. So there is also the issue of how to present this to stakeholders, how to deal with these models which can grow in a complex way. It's different to deal with. Other use, so we saw, yeah, usually the outcome is a climate risk report. So you do all this assessment, the modeling, etc., and then you write this report with recommendation. There are also other uses that we've experienced for impact change. One of which is, for example, for creating specially explicit indicators. So you see in this example, you had spatial explicit data on the components of risk, hazard, exposure, vulnerability, and then through the connections provided by the impact chains that were modeled for the project, then you actually compute indicators of risk in the different administrative regions. And this is a nice application. And also another one is to use the impact change, not just to have an overview of the current state of things and try to predict the near or mid-long term vulnerability to certain risks or hazards, but can also be used for, let's say, forensic analysis. So you can look back and analyze what happened during this very specific event, say the Vaya event here in South Tyrol, so that you can use this tool as a tool to learn from these events. Yeah, these are some pictures of what's been done in this sense. And very importantly, what impact chains are not, because I mean, they're of course not the only tool around to do such analysis. So not to get misled, I also reported what they are not. So we see that they are they do not represent an event or a set of environmental condition, but they want to represent the risk related to that event. So this is important. It is also not causal networks, which are an important modeling tool around. You might have heard of them. Impact chains are different from them because their relations have different types. They're not just causal as they are in causal networks. And they're also not meant to represent loops and feedback cycles. There are other diagram modeling tools for that. And yeah, one more thing is that they do not include generic type elements. Regarding causal networks, here are a couple of examples. So causal diagrams consist of nodes and arrows, like a bit the impact chains, and every arrow denotes a causal relationship from one node to another. So you have different types of diagrams of this type, like the Bayesian network here, or causal loop diagrams. So these are very interesting tools. They're just focused or meant for slightly different purposes. Okay, let's build an impact chain now before going to the end of the event and see what's in the lab. I wanted to build, I prepared a simple impact chain for you to be, we try to build it together a bit. And so that's, I think, a nice idea to get more the feeling of what's behind building one. But first of all, how do we build impact chain usually? So the most common way is to gather experts and stakeholders of risk of the area of interest and do, workshops together, 2 days workshop where ideas are collected from all the experts and all practitioners of risk. And so you see all the post-its and whiteboards. And after that, you go through the actual digital diagrams. You try to summarize and collect all the information into digital form. You can also, you see, it's called desk-based. So you can also skip if all the stakeholders meeting participatory process and go directly on this desk-based impact chain. That's what we've done anyway now. And okay, so remember scoping. This is the first step of climate risk assessment. So what does it mean? So there are different points for defining the scope. So you have operational, what is the operational framework of the assessment? Graphical context, of course, and administrative one. Temporal scopes, are you analyzing the past events? Are you just interested in the current state and very short-term future, or are you willing to do a much more long-term analysis? And finally, this is also very important. So you have to find it's like a trade-off between willing to model all the systems as much as possible, but also you need to force yourself to limit to specific sectors and systems of society. Keeping in mind that you have multi-risk, you have multi-hazard, so you also have to have a kind of systemic view of those things. You don't have to exclude sectors which for that specific types of hazards and impacts are very much related with that. So otherwise you lose part of the information. So, and then after the scoping, you start the analysis. So again, you start collecting information, for example, that you have collected through this participatory process with the stakeholders and the experts, and you put them in some simple tabular form. So on one side, you have what are the source of hazards, of climate hazards. For example, here we have heavy rain, strong wind, and then all the other elements of risk. So you have exposures, vulnerabilities, and impacts. And you collect, this is not really the only way to collect, this is a handy way to organize the information. So you, let's say by each element of exposure, you try to group together what are the impacts and vulnerabilities related to it. So for example, you see the railway infrastructure, a vulnerability index that can be applied to it is there a redundant way if something happens, like a landslide falls on the railway, Is there another alternative way to go through? So this is a way to define vulnerability for this kind of exposed element, and so on. So after you have filled all the table with all the information, you proceed with the digitization of this information. There are many different options. We also at Eurac Research we used several of them. Mine of choice now is Kumu, this tool, this free tool, which lets you, as you see in this screenshot, organize the diagram. So let's try to go to this Kumu project, and okay, this is, can you see right the browser?
Yes.
Yes, thanks. Okay, so this is imagine. So I from the table we saw before, I just ingested all these elements in the Kumu project. So first of all, you have the possibility to put a lot of metadata. Yeah, that's let's say basic functionalities, but I think they are very important. So when you create a project, you have the main metadata where you can put all the information you can store, and so it's not lost. All the information about the scoping of the impact chains that you are building. And you see this is just a markdown, and also at each element here, each box has its own metadata. You have a main description. This is already, of course, pre-filled, so we don't have to do it during the training event. And then you also we have defined a set of attributes which can be applied to each of the elements or each of the elements of a given type. So you see here you have the other called even tags, or you have attributes like what is the confidence. So what is the confidence you attribute to what you are stating in this box. You can usually what we do is to provide references to this information. They can be, you see, entities or even scientific papers, etc. And you have other attributes. So this is a bit the capabilities of Kumu. So usually, what we do is, by no means the only way, but usually what we do is we start from the hazard. So for example, imagine what can be the impacts of having strong wind gusts in area like ours, for example, in Bolzano. Usually these are in gray, are all the impacts I've collected for this impact chain. So you can imagine, I would say, like the falling of trees called wind throws is one direct impact of strong wind. So let's create the connection. I'll go sketch mode. So it's usually just connect the two boxes, and let me try again. Okay. Wait. Okay, sorry. Yeah. So I created this connection, and as you remember, the connection have different types in the impact chain. So what types of connection you see here from the legend on the bottom left? These are the different types of entities: hazard, impact, vulnerability, exposure, and adaptation option. And these lines are the different types of connection. You have the causes connection, affects or impacts, and mitigates and relates to. These are the different typology we have now here. So for our strong wind, it causes, so we have connection type, we put causes, and we're done. Okay. And then, of course, we can put description and any kind of sort of things. But let's continue with building the impact chain. So you can have, direct impact of hazard, but this is actually literally a chain of impact. So the idea is also that you try to represent how the cascading of an impact causes on other impacts. So what can the falling of trees cause on the exposure we have here? So for example, power disruption. So the falling of trees get cables down and causes power disruption. So let's put another connection here. Okay. And we put the tag causes again. So let's talk about now what, so this is an impact power disruption, but it's on a specific infrastructure exposed element, which is the power infrastructure, of course. So we will connect these two as well. So power infrastructure impacts on the power disruption impacts on the power infrastructure. So this is the connection we put here. You see connection type and then impacts. Okay. After this, for example, what is a vulnerability kind of information that can apply to the power disruption is, for example, the I know this is missing, but we can create one. So we can I know this is, let's add an element, type, vulnerability. It's the redundancy. So no redundancy of the infrastructure. Okay. Okay, and then we connect the two with an effects. Okay. And talking about now let's go to see also the other hazards and how they are interconnected. So heavy rain, one direct impact is that it will increase the probability of landslides if there are strong heavy rains on an area. So let's put this one here, and we will build the connections afterwards. So what can modulate the probability of landslide in an area? So given an area susceptible to landslides, if we have a change in land use, for example, this can make more areas more vulnerable, because you maybe lose protection forest to reuse the area for agriculture or something, but this exposes that area to more probability of landslide. So this is vulnerability. Let's sketch the connection here and here as well. Okay. And then if you have susceptibility to shallow landslide as well, this is another component that defines how vulnerable. Sorry, let's put it here, and let's put another connection. And how they become connected together. So for example, another impact that is caused by the falling of trees is the decrease in the so-called forest protective function. So of course, trees fall, and so they don't work anymore as their original function to protect the slope from landslides. So as we wait, sorry, as this gets moved, we move this one, and this is the actual connection, because let's build the connection. sketch. So we have the connection here, and the decrease in the protective power of forest also increases the probability of landslides. So you see here is we are connecting the two different sources of hazards together. And okay, so continuing on this, what is the exposure element that is more exposed to heavy rain, going back to the right side of the diagram? So in this case, we have mountain slope is what usually can be modeled as exposed element to this, and which is affected by the landslide. So the more landslides you have, the more the actual resource of the terrain of the slope is affected, and you cannot reuse it, or it's hardly reusable. And so let's build this, draw the connection here as well. So okay, so we have this, or let's exit sketch mode, sorry. So we have this, still these impacts and these other elements to be put. Let's put them and complete the impact chain. So for example, what causes the decrease in protective function in addition to the increase of probability of landslides? So this can also increase the probability of avalanches. It's the same way. So we build a connection here as well. And actually, the avalanches can affect another exposure elements in the model, which is the buildings. Of course, when buildings are more exposed to avalanches, they must be informed of such likelihood. So we have also this connection. And finally, very interesting, you might have heard of the bark beetle in recent years, which are eating our forests. So the interesting information is that when a tree falls, it actually works as a reservoir for bark beetles. And so whenever you have more trees falling, for example, due to strong winds, this creates a better conditions also for the outbreaks, possible outbreaks of the bark beetle. So here, sorry. So we have these other impacts which cascades from the wind falling of trees, okay? And of course, the pre-existing conditions of the protection forest increases also the vulnerability of the forest to the hazard. So whenever you have strong wind on already a section of the forest which was damaged, for example, by the bark beetle outbreaks itself, this becomes more vulnerable. So we added in the model as well. Put the connection here. I'm not typing the connection just to speed up a bit the demonstration, but we're almost done. Also, we have the lack of risk-aware forest planning. So whenever you don't have a proper risk government on the ecosystem, on the forest, that's another component that makes that section of forest more vulnerable to risk. And so we put this last connection here, and this is the impact chain that we have built. And just to also showcase a bit the perspective of adaptation. So this is the situation we have tried to model with the simple impact chains on the risk of both strong winds and heavy rain on these reduced sectors and systems of society, like power infrastructure and residential building, for example, and the mountain slope resources. How can we use impact chains to model recommendation and adaptation options to this? And one simple example is, for example, that if we recommend to, burying the power cables instead of having them exposed to the falling of trees, this can be an idea for adaptation. in case, you know, in the perspective of having the probability of strong winds increase in our areas, which is going to happen. This is, for example, a possibility. So bearing cable, we connect this power disruption potential impacts to this adaptation option here. And that's mostly it. I don't know if there are any questions. This is yeah, I try to keep it as simple as possible, but also you see there are some complexities, and you see the different cascading of different impacts coming from separate types of hazards, and how also what does it mean vulnerability. So how sometimes it's less easy to grasp the concept, but so this is I wanted to give you an idea of the kinds of information that are played within an impact chain. And if there are no questions here, I will then come back to the slides. Any questions? Okay, so I'll go back to the slides and go to the final section, which is, yeah, we wanted to talk about a bit the ongoing and future developments here at Eurac Research. Some of them related, of course, to CyclOps project. And so impact chains as a knowledge engineering tool. Of course, we were going in this direction. The impact chains cannot be just a drawing, so they have to be information which must be stored as a structured data. So to foster standardization and coherence, also through the use of ontologies, we are trying to go towards this from a drawings to an engineering tool. You have seen Kumu, for example. Now here, this is an option. You can export this impact chain to a JSON format, which then you can use and make it machine readable. You also, and then you also, we already did it in some projects like this CRISP project here, to import impact chains intertwined with ontologies in a virtual graph database. So to make some semantic reasoning, this is a website to showcase the result of the project. Regarding CyclOps, so the idea is to try to connect this qualitative, very much more qualitative assessment done in the impact chains with the quantitative world of data. And this is what we're trying to do also with CyclOps here. You see, you have an impact chain browser, and then through CyclOps, through the connection with data sources and data spaces, you can reason directly on the impact chain. And even so, going a bit beyond, we're trying also to see the possibility of developing climate storylines. This is a concept, a kind of relatively new concept. So again, through the connection with the quantitative world of data, try to see how can we ask the impact chain the alternative scenarios, or what if scenarios, like what if in this past event you had 20% more of rainfall precipitation, what would have happened? These kinds of information. Other ongoing devs, so there are impact chain guidelines being written currently, and we want also to build a tool to standardize the building of impact chains, include the time component, and how to use impact chains for develop the adaptation pathways, they are called. I'm done. Sorry for being a bit long. These are in the end just some links to, if you're interested in further reading about what we do, but also in general about climate risk assessment. I put here many interesting links, and also this very fresh new report from the UN University, this Interconnected Disaster Report 2025. I recommend, it's a recommended read. So yeah, I will probably put this presentation online somewhere as an author, or we'll see, and I will then share them to you. thank you. And if you have any questions, we'll be glad to answer. Thank you. 11 o'clock, right? Yes.
You have explained it very well. So.
It's been a lot of information. Sorry for that. I tried to put all the concepts that could be helpful to understand the whole concept. There is something in the chat, I see. Okay, very informative. Thank you very much. Good, I guess there are no questions. Let's wait one more minute. Otherwise, anyway, I guess Dolores, we will reach out with the link for getting the slides and the recording.
Yes, for sure.
Yeah.
For sure. Mm-hmm.
Thanks to all of you. I'm reading all the thanks. Thank you. Good. That was interesting. Yes. Okay. You can stop the recording, I think, if it's not done already. I think we're okay. Thanks all of you.